So like I said, one of the most exciting topics in Algebra 1, completing the square. So we're first going to do a little bit of review, which is sometimes quadratics work out really nicely, right? So if I had something like x squared plus 2x plus 1 equals 0, and I asked you to solve this, right, you would figure out eventually that this was x plus 1 times x plus 1 equals 0. And another way of writing this is x plus 1 squared equals 0. And this is really easy to solve now, right? But the way that we solve it is actually going to be a little different with completing the square. So we're going to take the square root of both sides. But when we do that, we're going to remember in most cases, so now we have x plus 1 equals 0, and we're subtracting 1 from both sides, so we would find that x equals negative 1. Just the same way that you would have by using our kind of zero product rule on this, we can take the square root of both sides and get the same answer. Okay, now sometimes they may not work out totally quite as nice as that. What if I had something like this? X squared plus 2x plus 1 equals, I don't know, 16. Now, the way that we've been doing these, you would subtract the 16 over here and then factor. But wait a second. Isn't there an easier way to do this? If this is still a perfect square, so this is still x plus 1 squared, and that equals 16, can't I now just take the square root of both sides and solve it that way? And the answer is yes. Yes, you can. But there is a trick. So this side, the square root of x plus 1 squared is x plus 1. But the square root of 16 is not 4. We're going to write it like this. The square root of 16 could be a positive 4, but it could also be a negative 4. So we're going to write plus or minus 4. Because negative 4 times negative 4 also equals 16. So then we subtract 1 from both sides. And x would equal, well, positive 4 minus 1 would be 3. But negative 4 minus 1 would be negative 5. And you would have gotten the same answer by factoring. But I think this is actually a little faster in this case. Because we had this perfect square. No, I certainly wouldn't take points off on a test. Unless I told you, complete the square.
What if it's not a perfect square?
Right. But what if it's not a perfect square? And that's the beauty of this, of solving things this way. Okay, that's where this is going to be really, really useful. So let's do a problem. So I'm going to make this a little bit different. Let's say we solved. We wanted to solve 4x squared minus 2x minus 5 equals 0. Now, we're going to solve this using what's called completing the square. We're going to end up doing this. Okay? But you'll notice we're not starting off with a perfect square. there's some steps that we're going to have to follow. Okay. We want this side to be a perfect square. And we can do that. We can always force it to be a perfect square. The first step in completing the square is going to be to move your constant to the other side of the equation. So in this case, I'm going to add 5 to both sides, and I'm going to always end up with an equation like this. 4x squared minus 2x equals 5. So when I'm completing the square, I want there to be no constant with my x's. The next thing that you have to do is you have to divide by a. So this trick will not work if you have a number here. So we're going to divide everything by 4. We're going to end up with x squared minus 1/2 x equals 5/4 in this case.
Wait, what did we divide by?
We divided by a, this number here. And the whole goal is to just have an x squared out front. Okay. Now this is the completing the square part. This is kind of the setup. We have it set up when we have x terms on one side, constant on the other side, and no number in front of x squared. So this one is set up correctly. Now, to find the square, to complete the square, we just look at this side and we say x squared minus 1/2 x plus something has to be a perfect square. And there's a trick for figuring out what this something is. Okay, so we're going to take 1/2 of this coefficient and square it. So if I have 1/2 of 1/2, that's 1/4. So we take 1/2 of b and square it. So 1/4, and then 1/4 squared is going to be 1/16. And that's the number that will make this a perfect square. Okay? And you're always going to be adding it, because perfect squares always have added last terms. Now, I can't just add 1/16 to that. I also need to add it to this side of my equation. Over here. Okay, this is kind of a self-checking step. What this should do, when you take 1/2 of b and square it, is it should make this whole side a perfect square. So, I should now have x plus, actually, in this case it's minus, x minus 1/4 squared should be the factored form of this side, if I did everything correctly. And on a quiz or a test, I would just quickly check your work. So x minus 1/4 times x minus 1/4, we're going to end up with x squared. We're going to end up with minus 1/4 x, and another minus 1/4 x, and then a plus 1/16. And these two combine to be minus 2/4 x, which is minus 1/2. So that does work. And the 1/4 is always going to be what I got when I got 1/2 of that. So I take 1/2 of my number in front of x. That's going to be the term that goes there. But I have to square it to find what I add to both sides. Now this equals, we have to simplify the other side. So this would be times 4 times 4, 20/16 plus 1/16. And so we'll just simplify that to 21/16. Now we take the square root of both sides. Like Lucinda was predicting, this time it's not a perfect square. In fact, it's kind of a really ugly number. This side is nice and simple, x minus a fourth
Wait, how'd you get
equals
21? Oh, wait.
20 plus 1. So I have to convert, to add these two fractions, I have to have the same denominator. So I do that. And then I know this is going to be the square root of 21 over square root of 16 is just 4. Well, that's kind of nice. I'm going to end up with the same denominators. And I know that this is plus or minus. So I just want to remember that. And then the way of writing the final answer here, you have x equals, we're going to add 1/4 to both sides. And the trick is to remember to write that first. So I'm going to write 1/4 plus or minus the square root of 21 over 4. And in this case, that actually could be kind of simplified a little more if you wanted to combine them over the same denominator. But you don't have to do that necessarily. So your answers are going to look really weird for some of these completing the square problems.
Wouldn't it just be easier the other way?
Yeah, it seems like it would be. But imagine what the factors would be. Right? The factors would be like really, really complicated. And actually, we don't really know a way to factor a problem like this. Because this number, right? We know the denominator would be like 4x. And then I think, the first one is definitely positive. And then the numerator is going to be like 1 plus the square root of 20. Like, that would not be something that we would be able to get to by factoring. And so what's going on here is these are types of quadratics that have roots. So they have zeros, and they cross the x-axis at really weird numbers, right? If you think about it, factoring only really works if we cross the x-axis at like an exact fraction, like 1/2 or 6/4. But sometimes you might cross the axis at square root of 27 over 7, right? There's no thing that says you have to cross the axis at a perfect place, where your zeros, your factors, always have to work out to rational numbers. And sometimes they don't. Sometimes they work out to irrational numbers. Okay, this is kind of complicated, so now I want to do a simpler example. And this is one that you could factor, but that's what makes it simpler. So we're going to follow all the simple steps. But I wanted to show you kind of why we would have to use this, right? In that case, you would have to use completing the square. You couldn't factor that. You wouldn't know how. So what if we had something like this? X squared plus 6x minus 7 equals 0. Now, you guys can probably see the factors of that, right? We've got like plus 7 and minus 1 would give us 6. But let's try solving this by completing the square. Okay. So first step, we're going to move the constant over. So x squared plus 6x. I'm going to leave my space equals 7. So I just added 7 to both sides. Right. The reason I left my space now, there is no a, so I don't have to divide by anything here. Instead, I just immediately move on to this step. I'm going to take half of 6, which is 3, and square it, which is 9. So I'm going to get x squared plus 6x plus 9 equals 7. Don't forget to add it to both sides. Equals 7 plus 9. Okay, now we've got x squared, x plus 3 squared, as our factored form of this. 7 plus 9 is just 16. Square root of both sides. You'd have x plus 3 equals plus or minus 4. Subtract 3 from both sides. And I always like to write that first. So x equals negative 3 plus or minus 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. So when the problem is simpler, this process is simpler too.
Why did we have to do 1 or negative 7?
Because we have negative 3 plus or minus 4. Okay. The square root of 16 is positive or negative 4. So then when we add 3, well, we add a negative 3. And if I were to really write this out, I have plus or minus 4 plus a negative 3. And then I'm using kind of the commutative property of addition. So I say negative 3 plus either a plus 4 or a minus 4. So negative 3 plus 4 or negative 3 minus 4, because plus a negative is minus. So it may be easier to write it out in this way. Write negative 3 plus 4 or negative 3 minus 4 and then solve. But you will end up with two answers unless it equals 0 in this step. Okay. Like right here. That's the only time you'll have one answer. Let's do another example, because I think that first example was so complicated. Let's try another simple one, just to get through the procedure. So, what if we had? We haven't done this one yet. Okay. X squared plus 6x plus 10. Alright, what's our first step? Subtract 10 from both sides. So I have x squared plus 6x, I'm going to leave a space, equals negative 10. Okay, I'm going to take half of 6, which is 3, square it, which is 9. I'm going to add 9 to both sides.
What if it's not an even number? Like, what if it was x squared plus 7?
Yeah, then you would have a fraction. Yeah, like that was the first one that we did. And those are the ones that are going to end up, you have to solve it this way, by completing this way. X squared plus 6x plus 9 equals negative 1. X plus 3 squared is the factored form of this. So that still equals negative 1. Take the square root of both sides. X plus 3 equals the square root of negative 1. Yeah, so we would say, for our purposes, we would say no real factors. And this is a good way to kind of prove to yourself that there are no factors. Because sometimes you may look at a problem and go, I can't think of the factors for that. Right? This will actually prove to you that there are no factors.
Wouldn't you subtract 3?
Yeah, but you could, but the square root of negative 1 is not possible. So Yeah, you're right. Like the last step normally would be x equals -3 plus or minus the square root of -1. And you will get to a point in Algebra 2 when you'll write these this way, and this will actually make sense to some degree. But for right now, this is not a real number. The square root of -1 is nothing. There's no two numbers that multiply to make -1 because you need a positive and a negative to make a negative. And so we're just going to say when we have the negative number under the square root, it doesn't matter what it is, it could be -762. There's not going to be any real factors if that is negative. So actually you can stop right in this step if you notice that you have a negative number on that side. But don't stop in this step because it's possible that you would add a number that would make that positive. So, okay.
So all the negatives would be, there would be no real factor?
When you have the square root of a negative. Not at the beginning. It doesn't matter at the beginning. It only matters at that like fourth step. Now let's do another one. Let's say 2x squared plus 8x plus, let's see. So, what's the first thing you're going to do here? Could. Yeah. Divide by 2. So you still want to look for these tricks. If I can divide out a greatest common factor, I still want to do that. X squared plus 4x plus 4 is going to equal 0 divided by 2, which is 0. Okay, now I want to subtract the 4 over. X squared plus 4x equals -4. Should we stop? I got a negative number. No, don't stop yet, because remember, we need to figure out if what we add is going to be bigger than 4. Actually, in this case, what we add is 4. Half of 4 is 2, and 2 squared is 4. Okay, this is a little weird. -4 plus 4 is just going to be 0. I kind of went backwards. So sometimes you'll actually have a perfect square here, and if you recognize it, you can save yourself a step. But following this procedure didn't hurt me at all. It still works. Right? I still got to my perfect square. Now I know this is going to be x plus 2 squared. That's going to be the factor form of that, equals 0. Square root of both sides. X plus 2 equals 0. And in this case, I don't need my plus or minus because 0 is always going to be 0. So I just subtract 2 from both sides. And x is -2. In this case, there's only one root. And what that means is that we have a parabola that sits on, if I drew it in the wrong place, but sits on the axis. So its vertex is going to be -2. And that's why we only get one root. So I'm kind of trying to show you that this procedure will always work, no matter what.